Presentation by Audie, Brock, and Jack. The goal of this lesson is to take the content from the previous lesson, max and mins, and implement them into solving harder application problems. The objectives of this lesson is solving word problems using max and mins, understanding the process, and to become comfortable with the questions themselves.
How to solve max and min word problems. First step is to read the problem and know what the question is asking. Second step is to draw a picture. Drawing a picture can help you visualize the problem. Third step is to define the variables given. Fourth step is to write down the equations that are related to your problem. And fifth step is to try and test your answer using the second derivative test. This will help you find the extrema.
To begin this problem, we recorded the equation that we got using the word problem. We also drew a picture to help us understand what we were looking at. To begin, we took x and x, 2x plus y, and wrote it down, because we are given that this equals 20. We also know that the area of a rectangle is length times width, or xy. So using this problem, 2x plus y equals 20, we can solve for y, which is just simple minus 2x, and you get y equals 20 minus 2x. Then using the area equation, x times y, we can substitute the y, which we know is 20 minus 2x, and get x times 20 minus 2x equals max. Then we can distribute the x, and from there we get 20x minus 2x squared equals the maximum. From here you just simply find the derivative, which is 20 minus 4x equals 0. Then you solve for the critical point, which we learned earlier is when the derivative equals 0. That happens to be x equals 5. From there, we take the x equals 5, plug it back into the original equation that we wrote down, 2x plus y equals 20, and we get 2 times 5, what we found for x, plus y equals 20, which is 10 plus y equals 20. You subtract the 10 from the 20, and you're left with y equals 10. So you know the dimensions. X is 5, and y is 10. And that's all there is to it. Now that you have the feel for the whole problem, we are now going to break down the problem into individual pieces to help you understand the problem itself better and how to solve them. To start, read the problem and draw a picture. So, you have the yard and the house. You have the house and the yard. Then label. You have x and you have y. So if you read the problem, you are given that the dimensions that produce a play yard of maximum area if 20 meters of fence is available. So you know that 2x plus y equals 20. You have an x right here, an x right here, and a y right here. Together, that should equal 20 meters of fence. You also know that area is x times y, so you can write that down as well. Area equals x times y. So, from there, you're going to go and take y and set it equal to y equals 20 minus 2x. That's the initial process you want to take. Now that you have the initial setup, 2x plus y equals 20, y equals 20 minus 2x, area equals x times y, you can take the substitution, y equals 20 minus 2x, and plug that into your area. So now you have area equals x times 20 minus 2x. This is a simple step, just substitute, and it's done. From there, you're going to want to distribute the x. So x times 20, 20x. X times 2x, or negative 2x, is negative 2x squared. And from there, you're going to want to find the derivative of this, which is 20 minus 4x equals 0. From here, you have to find what equals 0 now. So you subtract 20, and divide by -4, -4, and you get 5. So you now know that x equals 5. So you have one part of the dimension. If you go back to the picture we drew, which is this, you have the house, the yard, we had an x right here and a y. So this x right here is now 5. So you have half the problem done. Now that you know what x equals 5, you can return to the original problem, 2x plus y equals 20, and plug x into the x. So then you have 2 times 5 plus y equals 20. 10 plus y equals 20, minus 10, minus 10, y equals 10. Now you have both dimensions. The yard, the house, 5, 5, 10. 5 plus 5 is 10, plus 10 is 20. So now you know your dimensions. You might be wondering how this all relates to max and mins. Well, if you remember the problem we ended up getting after we substituted y, which was 20x minus 2x squared, you have to take the derivative of this. Now, if we remember what a max and min are, you can make a sine graph type thing. You have n being the critical point, which is when the derivative equals 0. And if you had negative, 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 positive, 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 then you know that this is a minimum because it's going from negative slope to positive slope. Now, how does this all relate? Well, when you take this and you find the derivative of this problem, you're left with 20 minus 4x. If you make this equal to 0, you're finding this point. You're finding n, or the critical point. Next, you can find the actual value by doing simple algebra, minus 20 divided by -4, and you end up getting x equals 5. We know that from the previous problem. Now this is important because this is a minimum, and that's what we're trying to find. We're trying to find the minimum amount of fence needed to actually fence in the area. That was the problem in the previous slide.